Somebody tell me, what's that word? You know this probably by now. What's that word we use to remember the three ratios? Josh? SOHCAHTOA. Can you spell it, Josh? Close. Yeah. You could write it down a few times, say it a bunch of times, make sure you read it over a few times. You don't want to get that wrong. On the quiz, you could look at it in your notes, put your notes away, get your quiz and write it down at the top, right? It's kind of cheesy, but you could do that, right? If you're not great at it, if you think you might forget it. Once you get that, how do I use it to write the formula? Who wants to give me one? Adam. Yeah, give me one of those three formulas.
Okay, so the first one.
Yep.
Sin is opposite over hypotenuse.
Nice. So opposite over hypotenuse, and the S is the sign. And what are we missing there to complete the formula? Theta, or the angle. Does it have to be the variable theta? No. If you wrote x there, it's not wrong. Okay, you can use whatever variable you want, but we tend to use theta. It's just the variable, it's the angle. Yeah. Do it. Yeah, you're right. It's cos or cosine. Yeah, and you don't have to know how to say it, so that's okay. Yeah.
Cos theta equals adjacent.
Nice. And then the last one. Who knows it, Jake? Opposite over adjacent. Tan theta. A lot of people get lazy and don't write it down when they're doing their practice. And you think you could do it for the test, but then you find out that actually you forget the theta or something, you end up losing those marks. So if you haven't been doing it, I really, really recommend, again, it's all about making your own life easy. People think that it's too big of a bother to write it down, I'm not going to do it. But if you write it down 3 or 4 times now, you'll remember it for the rest of your life, and you'll never have to worry about it again, kind of thing. So it's worth just a little bit of work up front, and then all of a sudden it pays off big time in the long run. It's less work in the long run, right? That's what I'm trying to say. So write it down a few times today when you're doing your practice. Write the formula down. Sine theta equals opposite over hypotenuse. Write that down exactly like you see it a few times, and then you'll be good on the quiz on Friday. Okay, same steps for finding an angle. So we're doing some trig today, and we're doing the test on Friday, and then we're moving away from trig, but we'll come back to it later in the year. And when we come back to it later in the year, we're going to mix up all the kinds of questions together. So we won't tell you, are you solving for a side or solving for an angle? But 90% of the problem is the same. All of the setup, you do it the same, whether it's one or the other. Okay, and it's just that last step on the calculator, basically, that's different. Okay, so it's not that big of a stretch to do that. So let's take a look at one. What's different about, so you want to draw this into your notes and label it properly. Remember what we talked about yesterday? Should look like a triangle, not a blob or something. And you want to label the right angle, add the measurements that you're given. And theta is the unknown in that top angle. That's what we're looking for. It really helps, and I think a lot of people don't do this, and again, they do themselves a disservice, but if you compare this to what we were doing yesterday, you were given the measurement of an angle, the value of an angle, so 53 degrees you were given, and you were given one side length, and the other side length was X, or Y, or A, or whatever. This time we're given 2 side lengths, and the angle is like the question mark. That's what we're looking for. So that's how it's different. And it helps for your brain to build the patterns and build the connections. Sort of, if you think about it that way, the more connections you try to make, the easier it is to, again, understand bigger picture and recall all of the information that you need when you're doing a test. So What's the first step? Brianna. Label the sides, and labeling the sides is basically the same. So what's the hypotenuse? 18. It's always across from the right angle. And yeah. Nice. And how do you know that? Very good. So the angle we're looking for is the angle that we're talking about. Again, just put your pencil down and watch for a minute. If I changed the angle, if I said, no, I don't want to find this one, I want to find this one, that changes what opposite is, right? So we're going to call this one opposite, but if I was looking for this angle, this would be opposite. Okay, and that's not something you really need to know right now, but you will eventually. And again, it's something that really is tricky for some people, so it's something that you should be aware of and be thinking about. No, good question. Hypotenuse is always hypotenuse. You never use 90 degrees in the formula. Some people try to do that and everything falls apart. So if you're doing like sine of 90, you're doing something wrong, or cos of 90 or tan of 90, something's wrong. Okay, you never use 90 as the angle, and hypotenuse is always hypotenuse. It's not opposite or adjacent. Then it wouldn't be the hypotenuse. So if you had a triangle without a 90-degree angle, then the longest side, we don't necessarily call it a hypotenuse for one, but also you can't use SOHCAHTOA. So SOHCAHTOA only works with right angle triangles when you have a hypotenuse, and it's obvious what the hypotenuse is, so it always works. Bella? Hi. He's not here today. Okay. All right, so which ratio are the next step? We've labeled the sides. We got to choose the correct ratio and write it down. Mackenzie, which one do you think we're going to use? Wait, let me start, because this is what I would do. Circle and circle. It brings your focus to those two. So, yeah, good. So, from SOHCAHTOA, which is sine, because we know opposite and we know hypotenuse. Nice, nice, nice. So sine, we write it down. This is what I'm talking about. You should write down that formula until it's burned into your brain. And then if you want to be lazy in your own practice and not write it down, I mean, I can't stop you. Sine theta is opposite over hypotenuse. And then step 3, sub in the values. Theta is what I'm looking for. I don't know it. So sine theta, opposite is 13. Hypotenuse is 18. And how do I solve this type? Like on the calculator, what's the trick, Taylor?
You shift sine.
Yep.
You shift sine and then bracket 13 divided by 18.
Yeah, very good. This is looking for an angle is the shift sign, right? Again, you got to know. If nobody ever taught you that, you would never figure it out on your own. Like that'd be insane, right? How would you ever figure that out? So that's something you got to know, practice, and think about a few times. Okay. And if you're doing a one-line calculator, listen carefully. 13 divided by 18 equals shift sign, right? That's how you would do that. We round angles typically to the nearest degree, and this rounds to 46 degrees for me. On your calculator, do shift sign bracket 18 divided by 13. Try that.
Wait, so on a one-line calculator, you do 13 divided by 18, shift
Equals,
shift sign.
got it. So, and if you have a one-line calculator, try this. 18 divided by 13 equals shift sign. Two-line calculator, shift sign bracket. Yours doesn't need brackets, but 18 divided by 13. Josh, what happened?
It's an
Error. Error? Who else did it? Error? 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 Did you get an error? Yeah, good. Very good. Error. Why? Who can explain why? This is tricky. Think about what sine is, what it's doing. Wonderful. Did you hear that? So that would be like, if it was sine theta, it would be like if the 18 was here and the 13 was here. Hypotenuse is on the bottom. So it's 13 divided by 18 is what it's supposed to be. If you flip that to 18 divided by 13, what's wrong with this triangle? The hypotenuse has to be longer. Your calculator knows that. So that's helpful. Now that works for sine and cosine only. It doesn't work for tan. If you think about it, you can figure out why. So for sine and cosine, it will give you an error in certain cases. Don't be too surprised if you get an error. It means you punched it in your calculator wrong. It might mean you forgot brackets. It might mean you wrote the numbers down wrong, upside down, or something like that. Okay. So there's a few things that can happen that'll give you an error. It is common in trigonometry when you're learning that you might get an error here or there working on your calculator. But very good understanding that if you flip them like that, that's why, because the hypotenuse has to be longer. So for sine and cosine, the bottom number has to be longer. Very interesting. All right, try this one. Copy it down. Try it yourself. Step 1, step 2, step 3, step 4. Label the sides first. That's the only thing you have to do to get started. All right, so you should have hypotenuse here. You should have opposite here. How many people have that? And that makes this adjacent. Awesome. So Noah, which ratio did you pick? Good. Tangent. Because if I circle these guys, I know the opposite and I know the adjacent. Looking for an angle again. I know two sides. How many people pick tangent? All right. So tan theta is opposite over adjacent. Here's another tricky question. So it's going to be tan theta. Opposite is 11.4. Adjacent is 5.1. If you got it upside down, hold on. And shift tan bracket. 11.4 divided by 5.1. I got 66 degrees. Is that right? That's what you got. Yeah, that's good. 65.9. So it depends on where you round to. Like I said, it doesn't even say. It doesn't actually say. So that's fine. Usually we round angles to the nearest degree, so we don't keep a decimal place. Side lengths we keep a decimal. Angles we don't. Not for me. It's not the end of the world. I want you to round correctly. I'm not as worried about where you round to. Probably on the test, it's going to say round side lengths to 1 decimal place, round angles to the nearest degree. So technically, you should be at a point in your life where you can follow instructions. But again, I would prefer, if you're going to do one either, that you round correctly, even if you don't round to the right decimal place. Adam, you had your hand back up?
No, I was just gonna say, because it was at like 65.8, so this one.
Yeah, that's right. You did it right. 65.9 is correct. And 66 is also correct. They're just rounded to different places. If you did tan theta equals 5.1 over 11.4, what is that doing? This is a hard question. Tan theta 5.1 over 11.4 would make theta shift tan bracket 5.1 divided by 11.4. Whoops. 20 gives me 24. What did I find there? Thomas? The other angle. If I switch opposite and adjacent, flip. If this is opposite to what? To that angle. So you found that angle. Look at this. Blow your mind. What's 66 plus 24? 90. Plus 90 is 180. Every triangle has to add up to 180. See how math always works? And trig will always do that. Like if you use trig to calculate and you do it correctly, you're never going to get angles that don't add to 180. Like never. Not possible. Okay? So that will always happen. That's a really neat little connection to make that. Again, will just help your understanding increase that much more. Any questions about that? Now, you don't need to necessarily know that. You need to be able to find the 66 in this case. But any questions? All right, let's try one more. How many people are done the whole question? Oh. Okay, let's see if I can catch up a little bit here. Some people get confused when they're doing a question like this and like there's nothing here. So they almost feel like they weren't supposed to do that. But all the time, you start at the angle, go across, that's opposite. Whether it's empty or not, that is still the opposite side. Don't let that, like it's playing a trick on your brain or something. And I just noticed that sometimes people like hesitate when opposite is empty. Hypotenuse never seems to be a problem. And then adjacent is what's left over. Which one of the three ratios is only one? Again, you go back up, you look at those three. Only one of them is adjacent and hypotenuse. Ethan? Very good. Cosine, cos theta is adjacent over hypotenuse. Cos theta is 7 over 9.4. So 9.4 is a hypotenuse. It's bigger. That makes sense. And you could try it the other way around. It'll give you an error, just like the last time that we talked about. And what'd you get for theta? 48 degrees. Anybody else get the same thing?
I have 42.
42? Oh. Okay, let me try it. Might be you might have hit sine by accident. Even if we had cos written down, you might have hit sine by accident because 42 would be the other angle. Shift cos bracket 7 divided by 9.4. 42, yeah. 48's the other angle though, right? So probably just use sine by accident. Any questions about that? Yeah, it's 42 is right in. No, I'm saying it is. If you use sine, you'll get 48. All right.